Problem number 7, it says which of the following functions are even, odd, or neither. And it lists all of these functions. So you've got f of x is equal to the absolute value of x minus 3, g of x is equal to the absolute value of x minus 3, h of x is equal to x minus 3, p of x is equal to x minus 3 quantity squared plus 3, q of x is equal to 1 over the square root of x squared plus 5, k of x is equal to x cubed minus 2x squared, L of x is equal to x to the 4th minus x squared, and R of x is equal to x cubed plus x to the 5th. We want even, odd, or neither. Or neither, however you say it. So, our even functions, remember, are when we can plug in a negative x and get the exact same equation. So if I plug in a negative x here, is my equation going to be the same? Well, no, it's not, because I'll have the absolute value of negative x minus 3, which is different than the absolute value of x minus 3. So f of x is not even. G of x, if I plug in a negative x or a positive x, does this equation change? And that does not change because we've got that absolute value, so it'll be even, or it'll be positive either way. So we know that g is one of our even functions. H of x, if I plug in a negative x, that changes my equation. So h of x is not even. P of x, again, same, negative x minus 3. When I would square that out, I would get powers that aren't even, so that means that when I plug it in, it's not going to change every term, or it's not going to be the same. Q of x, when I plug in negative x down here, negative x squared is still equal to x squared. So Q of x is going to be even. K of x, I've got x cubed. When I plug in a negative x, I get negative x cubed, so that is not the same. L of x, when I plug in a negative x to the 4th, that's equal to x to the 4th, minus negative x squared is equal to x squared, so actually L of x also stays the same. And then R of x, when I plug in a negative x, I get negative x cubed minus x to the 5th. So we found all our even functions, so now we want to go back and find the odd functions. And the odd functions, when we plug in a negative x, we have to change the whole function completely. So negative x minus 3, well, that's not going to change my whole function because I've still got that plus 3, or I've still got that minus 3 there. It's still going to stay minus 3. It's not going to become a positive 3. So that doesn't change. When I plug in a negative x here, well, we already know that g of x is even. We know that q of x is even. We know that L of x is even. When I plug in, so in h of x, when I plug in negative x, I get negative x minus 3. Well, that still does not change this minus 3, so that's not an even function. So far for neither, if it's not even or odd, it's neither. So we've got f, and we've got h. When I plug in a negative x for p, this squared out, remember, will give me x squared minus 6x plus 9 plus 3. So I'll have a term with an even degree and a term with an odd degree, meaning that it's neither going to be even or odd, because one term is going to change when I plug in a negative number, but not the whole thing. So that is also going to be either. For k of x, when I plug in negative x, again, I've got one term with an odd power and one term with an even power, which means that it's either going to completely change or completely stay the same. So that is also going to be a neither. And then r of x, we've got terms with two odd powers. So that is actually going to be odd, because when I plug in a negative x, I'm going to get negative x cubed minus x to the 5th. So that changes my signs for my whole equation. So the only odd function is r. So to solve this, remember, we're going to be looking at what happens when we plug in a negative x.